I want to talk about the last evolutionary step in computing, serverless. We heard a lot today morning, so I can skip the basic parts in my presentation. So I want to talk about troubleshooting serverless functions. There is none work done in this area because it's we are early adopters in this field. The most promising solution was a combined approach between debugging and monitoring. So as we already heard, serverless is not a very good chosen phrase for the computing paradigm. So as the majority of authors, we also stick that function as a service is is better to use than serverless, because things like Google App Engine, introduced in 2008, are also serverless for a user. So the characteristics, we had this tomorrow morning, a short recap. Stateless ephemeral functions, abstraction of nearly all operational tasks. Why is all in brackets? There are two things left, so the timeout to choose and the memory setting, and it's kind of an operational decision, as we see in the future work section also. Auto-scaling on demand. Scaling to 0 is quite cool for the pay-per-use billing model. And what's important for the work presented here are these three aspects, especially the ephemeral functions without a state, combined with the provider control over the whole hard and most of the software stack, in this highly parallel environment. So I hope I can show the whole paper in one slide. The situation is, this is a quote from the AWS serverless implementation guide. So as most middleware services, you highly depend on the logs afterwards to troubleshoot your implementation. The problem in logs is unstructured plain text messages enriched by metadata like timestamps, locations, and the situation in serverless and in most of the software engineering or programming or implementations are unit testing to guarantee functional correctness. And unit testing in the case of serverless is quite easy. We have a single function and can test this as a unit. The problem is, or the problem in this case, especially with plenty of log files and data, developer searches chaotically in log files, maybe a short motivation. You may already, all of you may know this, searching for a parameter to find the error in your implementation, or the parameters who cause this error. So the problem is also parameters are often missing. So during the implementation, developers forgot to log parameters or other environment stuff, and so troubleshooting a posteriori is not that easy. And there's also no major tooling to support cloud function debugging because of its early state. And also it's not that easy to set a breakpoint in your function when it is executed on a cluster on Amazon or Google or IBM. Microsoft Azure is the only platform, to my knowledge, which has a possibility to online debug cloud functions. So, and our contribution is mainly based on a black box testing approach to log input, context, and output for later debugging, and to define a agreed upon machine readable format to analyze log data automatically. And we use a template approach. So what I want to present is a cloud function lifecycle enriched by troubleshooting elements. So the first one, I have a pen and paper Java example now for the presentation. So what's important is the calculate function. So only the input with getter and setters. This is kind of our business knowledge for the next 10 minutes. And what I use is AWS Lambda as the most major platform to implement this. And this, basically the interface with the input and output, and then you have to override these method, input, and context, and then you can calculate or execute your business logic and return the result. That's not surprising. The next phase, what we've introduced and what's also supported by a tiny prototype we implemented, shown by this diamond, is the instrumentation phase. So as I said in a contribution, we argue that logging input and output and also the context is sufficient to reproduce errors. And what we do is we need this main business logic class, then the type of the result, the calculate method, the input data, and also logger, which is a bit different on different platforms. So the next step is then, after implementing and instrumenting the cloud function, we can deploy the cloud function via serverless framework or by hand. And the operating and monitoring phase is completely abstracted from the user, so without control. Okay, so what should be a basic functionality of all monitoring services is alerting in case of failures. Maybe set endpoints to a queue, notification system, or email endpoint. And what we did is for evaluating our concept, choosing the email endpoint, and by this trigger, which is the alert in this case, we analyze the log data, or more precise, start our prototype to do this analysis. So what we achieved through the logging of input, output, and context, and what's also one of the tiny contributions is a common format to have a agreed upon format between logging on the one side and the analysis on the other side. And what's then really easy is to create these test skeletons. So we have placeholders here. So the placeholders are this constant, and we replace basically the values here. Read or serialize the input values as JSON, read this via JSON, and then can also generate a basic handler function or test function for the handler. And the only thing a developer has to do is to think about the search condition in this case. And there are two steps maybe which are quite important. The first one is to start with a syntactically correct expression to get the test running and to have the possibility to debug your cloud function. And the second one is if you evaluated the input and get the correct output, to alter this and insert the correct output and insert this test in your test suite. Okay, and then we have the loop to find the cause of an error is basically a human task, and we start the implementation and maybe skip some of the further steps. So advantages and drawbacks. Advantages. The most important advantage is it saves a lot of time and it's quite easy, and most of the runtime bugs, which are quite tricky to reproduce, are tackled with this approach, with a low overhead in cost, which is one of the drawbacks. And I think the higher test coverage is also a side product. And what's cool for a developer is the increase in log information quality. So what I missed to mention is inside the created test file there is the log statement as a comment above the class. So if you're not sure or which environment parameters were important, you can also check and read the logs chaotically. The drawbacks are test case duplication, which means I have a single error in my code, and due to this high parallelism and maybe thousands or millions of executions, with this approach I get thousands and millions of test files and test cases. So the next step should be to think about automatically process to get this test deduplication problem solved. And the other drawback is that logging extends the cloud function time, so the execution time, and in serverless, as we learned in the morning, time is money. So we also have to investigate how big this impact is. So that's basically the future work for the presented paper. So to get this deduplication running in concept and also inside the prototype, and to make a few benchmarks how important or how dramatically is the cost drawback. And what I also want to, because the audience is, it's quite cool to get feedback during the closer session. My next steps or my plans for the next research objects. What's already running is a cold start investigation, as we saw in the morning with the combining or the sequence of two functions. When you're running in two cold starts or n cold starts, sometimes it gets response time which is not acceptable for users. So I think this is, in the area of serverless, a really important problem to tackle. Then the comparison to virtual machines, containers, and paths, which is also often mentioned in literature, but not directly investigated. And what's also interesting is, so maybe two objects, is the main price for a single execution, because you can alter time and especially memory. Memory has a huge impact because if you double the memory, you get double the CPU cycles. So sometimes it's cheaper to use a higher memory setting, regardless if you need it or if you need it.
Okay.
Okay.
Thank you very much. Maybe a short question. There is an important one, but this is not the case. So thank you again. The next speaker is Justus Bogner. He will speak about evolution qualities of service and microservice-based systems.